So TApp getting hacked is an interesting case because it's not really a hack. No existing security measures were breached, no 0-day vulnerabilities were exploited, no unpatched CVs were exploited. It's basically what's called a data extraction. There was data on a public bucket and people extracted it. That's it. So typically when any product worth its salt goes into production, there is usually a risk assessment that is done by people who are experienced with this kind of stuff. Not every application gets this, but usually if an application has government oversight, if it is subject to legal or regulatory frameworks, or if an application has a critical business impact, there has to be a risk assessment, especially if you're a company that is funded by other people's money. And if this risk assessment is done with an existing framework, a structured set of controls in mind, then data extraction is one of the key risks that these control frameworks usually focus on. So for an example, the focus on data extraction is why you can't usually use production data in a test environment, because you have to have that separation between production data, real world data, and whatever you would do in your test environment, which can be less secure because you need to iterate through your development cycle. But it turns out no one who was involved in this application, T application, ever thought of this risk. There's even some rumors that this application was wipe coded, which I don't really think was the case, but it looks like the people who were actually involved in decision making in this application never really had the qualifications or the experience to actually handle the type of data that they were asking from their users. Right, so if you're new to the channel, I usually make videos like this, videos on cloud architecture, software engineering, and related topics, I guess. So if you're interested, consider subscribing, because that number going up means a lot to me. But also these topics can be helpful sometimes. No pressure if you don't. Let's get back to the video. So there were two compromises. One was apparently based on a descriptor file that had a list of file URLs that were available on a public bucket, a storage bucket in Firebase. And the second hack was basically their entire database, or a large part of their database, getting compromised. So private messages between users that were supposed to be private had been leaked in plain text. Now I could find screenshots and everything else that was related to the first hack, but I couldn't find any details on how the second compromise actually happened. But it looks like even after the first hack was publicized, they still didn't really focus on their infrastructure, their cloud security, all of the general security stuff that you do if you're sane. So it looks like what happened was, from the first hack, they got more exposure to outside world, and people started looking closely and found that the database was public. I don't know enough detail to say exactly, but apparently that's what happened. So as someone who's obsessed with cloud and software architecture and cloud security in general, I was really confused as to why people keep making this mistake of making resources public and hoping no one would find out, because that's not the reality. If you make resources public, people are going to find out. If you do even a brief look at general cloud architecture principles, not necessarily AWS, GCP or Azure, it doesn't have to be cloud provider specific. If you just look at basic security principles, you know that you shouldn't make storage buckets public. I wish that's one of the first things that people keep teaching to newcomers, and it's the same for other resources as well. You shouldn't have your databases in public networks. If you design a really common VPC architecture, you have your databases in a private network, you have your application layer, the backend layer, which actually accesses the database. The front end doesn't necessarily need to access the database directly, so you don't really need to have your database in a public network. Same goes for storage buckets, because you don't really need to make your buckets public for you to make them available to your users. You can have your software layer do your authorization. You can have features that are native to the cloud provider, IAM features or whatever, to handle fine-grained authorization in the cloud itself. So I kind of wanted to replicate what happened at T. So it's kind of like a post-mortem, but trying to reproduce the whole thing again. So by doing this, I wanted to understand a few things. I wanted to understand why people keep making this common mistake, and I also wanted to understand if, you know, a certain application was actually wipe coded, if it was possible to make the same mistake if you just ask an LLM to generate an application. I also wanted to understand if a fairly inexperienced developer would make the same mistake, given that they don't really have a high level idea of how the entire software system gets deployed. So in this exercise, I made a couple of assumptions. I was going to vibe code the whole thing. I wasn't going to get involved too much in the code. So in that regard, I was going to act as that product manager / non-technical business requirement person who just gives you the business requirement and doesn't really focus on technical matters that much. And the second assumption was that data during both compromises were publicly available. So that means the resources were public themselves, not any temporary URLs that get generated when the application is run as expected. And the third assumption is that there was some minimal security reviews involved, because I can't really imagine that someone who's involved in building software and building a company around a software product would not do any security reviews. So there's going to be some focus on security of the application as a whole, but there isn't going to be any in-depth security review. There isn't going to be any audit or something like that. So it's just vibe coded code on vibe coded cloud infrastructure and just minimal security for my application. So my application Greentea is a really simple web application that allows a user to create accounts, log in, and then upload a photo and then view all the photos that they uploaded. So the prompt I provided to the model was basically that: just create a web app, make use of GCP Firebase, and use White React for the front-end framework. So within about 2 hours, I was basically done. Most of the time was spent on reading Firebase documentation and thinking carefully about putting my credit card in GCP, because I didn't really have a personal GCP account. And other than that, most of the work was done by the model, and I was just watching the model generate code. So the first application I made was basically something like this, where the React application was directly talking to Firebase services. And if you've worked with Firebase before, you know that it's basically a collection of services that allows you to build web applications comparatively faster. So you have an authentication model, you have storage, you have databases, you have all the other services that you can use for a fairly complex web application. In this case, I'm going to use Firebase Auth for obviously authentication, sign up, sign in, all of that. Firebase storage is something like S3 buckets. I'm going to store the photos the users upload in that bucket, and I'm going to use Firebase database to store the metadata produced by all of those actions. So the application that got generated was a fairly straightforward one. This code is relatively easy to go through if you're a front-end engineer. I'm not really a front-end engineer, but I can navigate around the code. I can build something from scratch if pressured to, but at this point I was just focused on what happened at T, so I didn't really want to spend too much time on writing React myself. So if I go to the application itself, it's basically something like this, something like a Facebook timeline. You can upload photos and you can view the uploaded photos with timestamps and everything else, and this works with that architecture that I just talked about. So I want to emphasize the fact that I vibe coded the whole application from the start, because I want to show that there was no explicit software or cloud architecture design involved in this, and I wanted to show you that even if that was the case, you couldn't really get a model to build an insecure application, because while this application was being built, the model actually provided me instruction on how to create the cloud infrastructure resources by hand. So I didn't really generate Terraform for this Firebase based application. So I had to go into Firebase, sign up for a GCP billing plan, create the storage bucket, create the database, all of that. And while doing that, the model actually provided me a really sensible security access rule to be applied to the storage bucket and also to the database itself. So if I go to GCP Firebase itself and into the storage bucket and into rules, so this is the access rule that was provided to me by the model. Granted that I explicitly asked it to restrict accessing a user's photos for the user only, so there is that additional condition of checking the user ID in the request. But overall, this was basically the default rule that was provided by the model. Now, let's say this application was not wipe coded. It was made by someone who's not really experienced in GCP, Firebase, or in cloud in general. But even in that case, if you try to create a storage bucket, Firebase will actually want you to define if it is going to be in production mode or test mode. And if it is in production mode, it's going to apply a default private access rule. So by default, GCP would not have a public resource, a public storage bucket, if you try to do it all by yourself. Same goes for the database. The model actually provided me sensible rules to do fine-grained authorization, and GCP warns you if you try to make this public. More and more evidence shows that even if you try too hard to make an insecure application in 2025 with these cloud providers, you can't really do that unless you're making an explicit decision. Now, I know that I said that there'll be minimal security reviews, so what I did was to go to the browser tab, open the developer console, and check the network tab to see if there are any network calls that might be insecure. At first, the code that was generated by the model actually used a method in Firebase SDK called getDownloadURL, which actually generates a short-lived access URL for a specific file with an opaque token attached to the URL itself. So you can basically copy the URL, go to an unauthenticated session, a private browser, and then put the URL and access the file. But this token is generated with user credentials in the session. So without user credentials, you can't really iterate through a whole bucket of resources, for example. And the token itself is short-lived. So I don't think it was this standard way of accessing was the place that got exploited, because if someone wants to access all the files based on this approach, then they'd need to have access to all the user sessions, which again is not something possible. So just to make things really opaque, I changed the implementation from this get download URL to something like get blob or get bytes, because that downloads the actual file content to the browser instead of providing a URL to the browser to load. But in typical applications, you don't really need to go for this because get download URL will just generate a short-lived signed URL. Now, within about 2 hours and essentially 1 hour, without knowing too much about Firebase, I was able to generate a reasonably secure web application. Yes, it's a simple web application, but again, it is reasonably secure. Granted, if someone wants to point Burp Suite or something like that towards the application, they would probably find a few gaps in typical web application security, but this is a fairly reasonable point to start with. So I felt a little bit empty, because if this is all what it takes to generate reasonably secure code, then what went wrong, right? Maybe I missed something. Maybe there was something stupid that I forgot to do. So I wanted to replicate the same thing in AWS. So I asked the model to generate another version of the application, but instead of using GCP Firebase, this time using AWS services. So it'll be Amplify, S3, DynamoDB, Cognito, and AppSync for the features of the application. So the version of the application that got generated looks like this. And if you're familiar with AWS like I am, I'm more familiar with AWS than GCP. So this is what it looks like. Amplify again is like Firebase, but it basically is a wrapper layer around, let's call them large scale services in AWS. So Amplify Auth depends on Amazon Cognito. Storage is front end for S3, and database uses AppSync for a GraphQL interface, and DynamoDB acts as the actual database. So with that, the application that got generated looks similar. I added the usual AWS orange color to the application, but basically it does the same. It allows the user to log in, upload, and view photos. So code-wise, there isn't really anything remarkable to talk about here. It basically does the same thing as the Firebase version, but instead of Firebase storage, it uses S3 to generate a signed URL, which is again short-lived. So again, it was fairly easy to not build an insecure application. Now, granted, there were some Cognito identity pool stuff happening for fine-grained authorization in the S3 bucket that I didn't really like. I would have addressed it in software itself. But again, this was wipe-coded the software and the cloud architecture. So I don't really mind if it does the job, then it's fine with me. And I don't know what to say. Every time I try to act like a dumbass and build a dumbass application, I can't really do it, even when I try to get a large language model to build the whole thing from scratch. So what are the lessons from this exercise? The first lesson that I think is really obvious is that security is not a technical field. You don't really have to be a software engineer that codes 24/7 to understand security of a cloud architecture, security of a software design. In fact, I would even argue that being a software engineer is actually too focused, too tunnel visioned to understand cloud-wide security principles. And if you are going to collect data from users, you should at least be experienced enough to know that making a storage bucket public, making cloud resources public, is the first step of series of stupid mistakes. So the rule of thumb that I can give you at this point is, if you ever think maybe I should make the bucket public, there's a 99% chance that you have already fucked up. So acknowledge your mistake, take a step back and correct course. Of course, there's going to be some occasions where you are going to have to make your bucket public, but that's because you want to make your data public so that everyone else can access them. Government issued ID cards, selfies, private messages, these are not data that you should make available for everyone to download. If you didn't know this fact, that's one free tip from me. If you're really new to this area, check out data classification systems and data classification regulatory frameworks that would be applicable to your legal jurisdiction. So usually countries have their own set of data classification systems, and I think in United States, for different states, there are different regulatory frameworks that should be applied when a company like this has a software product like this. So the other lesson that I can talk about here is that AI or large language models or whatever you want to call it, that's not going to fix stupid. If you don't understand security, you wouldn't understand what code, what architecture, what kind of a cloud design gets generated by the model. So you wouldn't have the capability to actually understand how to fix stuff. So if you are a company, if you are someone who has an idea, and you want to build it faster, just do yourself a favor, hire someone experienced enough to architect solutions, not just write code, because you're going to need that experience if your product is going to be customer facing. The third lesson I can talk about here is that it doesn't matter if the application is as simple as the one I generated, because I really think the more complex an application is, the more eyes would be on places like resources that might be public, the more passes you would have along the architecture if an application is complex enough. So an application as relatively complex as the T app would have had several people looking at these points to see if they are actually building a good product. This is why I really think, and I want to add a disclaimer here, this is just my speculation, I don't really know what happened, I'm just speculating that these resources were made public explicitly by some dumbass decision. I know the words that I'm using to describe the situation is a little bit harsh compared to my other videos, but there were photos that got uploaded and got extracted that still had their original EXIF data attached to the photos. So if you don't know what EXIF data is, EXIF is basically metadata attached to photos and videos at the time they are generated. So every time you take a photo from your phone, your DSLR camera, your other cameras, there's a bunch of metadata that gets added to the photo itself. This metadata includes the date the photo was taken, the device description, and even data like focal length, aperture size, and everything else. But most importantly, most devices, if they have the capability, add the GPS locations where the photo was taken. So every photo that got uploaded into T had their EXIF data, which had the GPS location. So everyone whose photos were leaked have their locations exposed right now, and I think there are even applications, pinpoints, where every photo was taken. So how many thousands of users that got exposed have been doxed by the app itself. So I really think the owners of this company, people who funded it, people who built the product, should be held responsible. There's no need for new laws to be applied here. if you're handling PII data, personally identifiable information data, then there are already existing regulatory frameworks that forces you to handle that data carefully. But at the end of the day, the responsibility was with the application itself, the company itself. They are obligated, they are legally bound to protect this data. So I'm really keen to know what kind of outcome would happen from this whole thing. We can't really encourage companies to mishandle private data like this and expect to go on like nothing ever happened. So that's basically my 2 cents on the subject. I don't usually wipe code. I do use LLMs from time to time for other purposes, but this was an interesting exercise. But that's it for me. Thank you so much for watching. I'll see you in the next video.